Welcome back. Now let's look at paper 42 from October-November 2023. And as always with these paper 4 practicals, well, we're going to need two things, right? One is going to be the source files, where of course, well, this is like, let's say the text files, right, that we're going to read in. And then we're also the evidence document where we're going to paste our answers, paste our screenshots. Now, if you don't have these, of course, well, just go to any past paper website, okay? You should be able to find those. And why I guess if you've seen the other videos, then I'm going to code in Java. Although I will try to keep the descriptions, relatively language independent. And yeah, I will also have both the Python and Visual Basic answers right up on the side of the screen as well. Okay, so well, this first part is just saying, how to save the files, how to name the files, right, things like that. It also says a class declaration can be used to declare a record, which, yeah, I think I noticed in the previous video, especially in Java, right, records are going to be immutable, which means that, well, when we create a record, we actually can't change the values after that. Whereas, yeah, well, I guess, right, a class is not going to have that problem. Right, so number one, a program stores lowercase letters in two stacks. One stack stores vowels, right, so we're A, E, I, O, and U. One stack stores consonants, right, that's letters that are not vowels. Each stack is implemented as a 1D array, and we want to write program code to declare two 1D global arrays. Right, that's going to be stack vowel and stack consonant. Where each array needs to store up to 100 letters. The index of the first element in each array is 0. And right, well, okay, if you're writing in Python, include declarations using comments. Okay, so yeah, hang on then, let's just copy this. Or yeah, I mean, probably I can remember, so stack vowel, stack consonant. Right, so let's go here then, and right, this is going to be static. And right, this is going to be what I think a right char array, because it said yeah, okay, so well, 100 letters. I mean, I guess we can make it a string array if we want. Although I guess technically, yeah, we can use a char array, right, since it's only individual characters. Alright, so yeah, I think stack vowel, or was it vowels? Yeah, okay, right, not a plural, right, so stack vowel, that's going to be new char array. And then, of course, right, we can just go 100. And then, I mean, here, right, since it's going to be the same, well, let's just copy it. And then we'll just go stack consonant. Okay, so yeah, hopefully that should be okay for 2 marks. Right, then the global variable vowel top is the pointer that stores the index of the next free space in stack vowel. Yeah, likewise consonant top, right? Yeah, well, the next free space in stack consonant. Right, well, both of these are initialized to 0, and write program code to declare and initialize the two variables. Alright, so again, I mean, yeah, hopefully this is quite easy, especially since they tell us to initialize it to 0. Right, so let's go static int. This is, yeah, I think vowel top. Right, so that's going to be 0, and then, I mean, well, here, yeah, okay, well, let's do it on another line. And again, right, I'm just going to copy this. And right, let's just go consonant top. Yeah, so that should be okay. Right, then the procedure push data takes one letter as a parameter. If the parameter is a vowel, it's pushed onto stack vowel and the relevant pointer is updated. Right, if the stack is full, a suitable message is output. Well, then it just says, right, if it's a consonant, yeah, push it onto the consonant stack. Again, if it's full, right, output an error message. Right, and then it says you do not need to validate that the parameter is a letter. So notice that, well, of course, right, it says we don't need to validate it's a letter. However, maybe we won't, yeah, maybe this could also be what, I guess, an uppercase or lowercase. And in this case, yeah, I think, did it say it's going to store lowercase vowels, or yeah, lowercase letters? Yeah, okay, right, so a program stores, right, lowercase letters. So I think here, probably that means, well, we're going to want to convert this to lowercase. Because, I mean, well, possibly they're only going to be lowercase inputs. But yeah, possibly, there might also be uppercase inputs as well. Yeah, they don't really specify. And in fact, hang on, let's just copy these instructions. Right, okay, so yeah, I think if we go here then, and in fact, let's actually just demonstrate how to do this. So what I'm going to do, like, I'm just going to use a stack of, let's say, 3. Yeah, just to, keep it smaller. Yeah, that's a terrible drawing. Right, so here then they're saying what the top of stack pointer is going to start at 0. Now, of course, what if we push something? Well, I mean, let's just push A, for example. What then, of course, well, yeah, this top stack is going to increment. Right, then let's say, for example, we push B, right, it's going to increment again. Right, then if we push C, well, it's going to increment again. And this is going to be how we check if the stack is full. So let's think here, right, well, this is index 0, this is index 1, this is, right, index 2, index 3. And in this case, what we say the array size, right, or the stack size is 3. So effectively what we're saying then as well, right, when the stack size is equal to the top pointer, well, yeah, this means the stack is full. Right, so that's also going to be one check we need to do. Yeah, so let's just comment all of that, and then, well, let's try and write this quickly. So, right, let's go public static, right, it's a procedure, so we'll go void. Right, this is going to be push data. Right, it's going to take a letter as a parameter, so let's say char, I guess let's just say letter. Right now, if we want to convert to lowercase, I mean, there's going to be a few ways. Well, one, we can actually use the character class, and let's go right character, yeah, to lowercase, and then just letter like this. So, I mean, this is probably the simple way. Right, we can also use another way using the ASCII codes. And if we think what that in, yeah, let's say in uppercase A, well, uppercase A is going to be 65, right, and then uppercase Z is going to be 90. So what we can do is, well, we can check, right, if letter is what greater than or equal to 65, yeah, and letter is what less than or equal to 90. Well, then what we want to do, yeah, we just want to reassign letter. And that's going to be equal to, and right, I mean, here we're going to need to, you know, convert from, I guess, well, sort of, yeah, chars to integers, right, then, yeah, probably back to a character. So, for example, if we just do this, right, if we go, what, letter, and then it's going to be plus 32, because the difference, well, again, we say big A is 65, right, but then small a is going to be, well, 97, right, so, of course, yeah, well, the difference is plus 32, and actually, the reason they chose the 32 difference is because, well, in order to convert from uppercase to lowercase, right, all we have to do is just flip one of the bits, and that's going to be bit 6, right, because, I mean, bit 6 has the value 32, so, of course, yeah, I guess if you want to set, if you want to convert from lowercase to positive, sorry, yeah, okay, from lowercase to uppercase, then you're going to set that bit to a 0, right, if you want to convert from uppercase to lowercase, right, with the, well, then you're going to set it to a 1. But I think here, right, so I mean this is going to be an integer, so then we just need to convert this back to a char. So I think hopefully we can just put that in brackets, and then if we just go char like that, yeah, okay, right, so that's going to cast it back to a character. Right, so I think, yeah, I'm just going to use this method, although of course, yeah, you can use the, you know, the built-in character one, that's also fine. Right, okay, so here then, well, we want to check if it's a vowel. And I guess there's a few ways we can check as a vowel. I mean, either, well, I mean, one way we can use a set, right, so have a set of all the vowels. I guess the simple way is just an if statement. Alright, I think maybe I'm just going to use a switch statement. So let's go letter. And then here, well, the cases, so what we're going to have A, right, there's going to be E, yeah, it's going to be what I, and then, right, O and U. Right, so in these cases, well, let's think what we want to do. I guess first, and of course this is where we're pushing. So we want to check what if the vowel top, and I think actually what I'm going to do, I'm just going to make this smaller. So just for testing, right, I'm going to make, maybe just make it like 3. So yeah, right, well, right, let's make it a constant. So we'll go, right, final static, right, let's say int, and we'll go, yeah, I guess like stack size. Right, just make that 3, and then here, yeah, let's go stack size. And of course, you know, when it comes to actually, well, sort of, yeah, running the final code, of course, we'll make sure to set this back to 100. But yeah, I mean, just to make it easier to test. Right, so here then we want to check if the vowel top, right, is equal to stack size. Hang on. Right, okay, so if it's equal to stack size, what then it says we just want to output an error message. Yeah, so a suitable message is output. Yeah, I don't know, let's say can't push. Or let's say can't push vowel, and then we'll have the actual letter, and then let's have what I say, yeah, stack is full. Yeah, alright, let's say like vowel stack is full. And I'm probably just going to put that inside single quotes. So yeah, this should what should say can't push vowel, and then what's going to be, for example, A, right, inside single quotes. Yeah, since we just end it there. Alright, and then what if it's okay, I guess what we want to think then, we want to, well, because, like, if we think, so currently, and again, maybe I'll just draw it again, so what, we've got 3 elements. Now, we say that automatically, right, I mean, this is pointing to the next element, so we can actually insert first, right, and then after we've inserted, then we would increment. Whereas, of course, yes, sometimes, well, I guess, right, okay, you'd say if it's pointing to the current element. So if we have a stack like this, where let's say, right, currently it's pointing to the current element, well then, of course, what we have to increment first, right, then insert. But yeah, since here it's pointing to the next element, well, we're going to insert, right, then increment after. So yeah, let's do that then. Right, we want to go, I guess, right, okay, stack val, and that's going to be our index val top. Right, and then what we're just going to set, well, we're just going to assign that the letter. Right, then we can just, yeah, increment val top. Yeah, and I mean, I think that should work. And then, I mean, since there's a case, well, of course, right, let's make sure to use a break. Because, well, otherwise, if we don't use a break, then it's going to automatically execute the next case condition as well. Now, of course, well, currently we don't have another case condition. But, you know, when we add the default in a minute, and yeah, the default is going to be, well, like, I mean, okay, I mean, basically the default is the else, right? So if it's not, you know, well, yeah, if it's not any of these cases, well, then it's going to do the default. And I mean, if you're familiar with, you know, case in pseudocode, well, that's going to be the otherwise. But I think what I'm going to do, like, I'm just going to test it just with the vowels. Because the thing is, like, let's say if the vowels is wrong, well, then when I copy it, I'm just going to be copying the wrong code. Because, I mean, really, consonants, probably all we have to do is, you know, of course, we'll change that consonant top, you know, consonant top, yeah, stack consonant. So, yeah, I mean, let's just make sure this one is working first. Right, so let's go, push data, and let's just push A. And I guess, well, let's try and push, I guess, 4, because, well, the fourth one should give an error. So, right, let's go E, let's go I, and, yeah, let's go, for example, O. I think what I'm going to do, let's just also print out, we'll go, right, arrays, yeah, arrays to string, and that's going to be the stack val. And then let's also just, hang on, right, okay, let's also just output the, yeah, let's go the val top, right, and of course, well, this should say 3. Yeah, so let's try and run this, right, see if it's working. Yeah, and I think the first time it takes a little while to compile. Yeah, okay, right, so can't push val O, right, val stack is full. Yeah, then we get this, and yeah, the top is 3. Alright, so I think that's fine, and then what we can do then, well, let's just copy this. Right, let's just go for the default. Yeah, and then, I mean, I guess really for the default we don't need a break, well, since, you know, there's nothing after it, but yeah, let's just have it anyway. Right, let's go consonant top, and right, let's say consonant, and then yeah, let's say, right, consonant stack. And of course, you know, this is why it's good to test it first, because, well, otherwise, yeah, otherwise, like, maybe you're just, you know, copying and pasting the wrong code, and then of course you have to change it in, you know, 2 places. Okay, yeah, so I think that one should be okay then. Yeah, okay, right, so I think that's all we have to do. Right, then the file stack data txt stores 100 lowercase letters. Right, the procedure read data reads each letter from the file and uses push data to push each letter onto its appropriate stack. Right, use appropriate exception handling if the file does not exist. Okay, so yeah, let's just copy this again then. And then, right, hang on, wait, so this was called read data. Yeah, okay, right, so let's just comment this, and right, let's go, okay, so again, this is another procedure, so right, let's go public static void, right, read data, right, this doesn't have any parameters. Now, if we're reading files, well, let's go buffered reader, right, br, right, that's going to be new buffered reader, and then here we can go, what, new file reader, and then what here is where we just have the file name, so yeah, that's going to be stack data txt. And then right here it's going to do it automatically in IntelliJ. So let's go more actions, and we'll go surround with try catch. Now, of course, you know, we could do that ourselves, but yeah, I think it's easier to let IntelliJ do it. And then it says, well, yeah, use appropriate exception handling if the file doesn't exist. So I mean, here we've got this. Like, maybe I'm just going to output a message as well. Let's say, I don't know, yeah, like error. I mean, like, honestly, I mean, it's going to tell us this probably in this, yeah, runtime exception anyway. But let's go stack data.txt, right, doesn't exist. Yeah, just have that additional error. And to be honest, you know, you can also go, right, is it, wait, system.error? Okay, right, yeah, system.error.println. And yeah, that'll just, you know, print it in red. But yeah, so I guess, you know, that's also okay if you want. Right, then what do we want to do? So, right, we just want to read each letter and then, well, push it into the correct stack. So in order to read, well, let's go string. And I mean, notice that, well, okay, so I've got the file here already. I mean, since it's only 1 character, of course, we could store that as a char. But I think buffered reader doesn't really have a good way to read a char, or well, I guess like maybe it does, but the problem with that is, well, if we read character by character, then it's also going to read this new line character at the end. And of course, I mean, here that's invisible, but like this is actually going to be stored, well, of course, what small a is going to be 97, right? Then you're going to have, I mean, well, so the new line character, right, this \n, and I think that's just ASCII code 10. So for example, if you open this file in a hex editor, right, it's going to be, for example, what, like 97, right, then it's going to say 10, because, well, 10 is the new line character, right, then it's going to be, 98, right, then it's going to be, another 10. So I think what I'm going to do, I'm just going to read the entire line, and then, I'll just get the first character from that line. Right, so let's say line, right, that's going to be, an empty string, and so, I mean, similar to pseudocode, where, of course, we're checking kind of, sort of, I mean, well, okay, kind of like, while not at the end of the file. So it's going to be, right, line equals, and this is going to be, right, br.readline, and we're just checking that that's not equal to null. Right, and then here again it's going to say we need to add another catch, so let's add that catch clause. And then here, like, I guess we can just make a char, right, let's just call it letter. Right, and then that's going to be line, and then let's go char at, right, and let's go char at 0, so just the first character on the line. And then, I mean, I guess then what we can just call push data. Since, I mean, push data is going to actually handle, whether to add it to the right, vowel or consonant stack. Right, so let's go letter like that, and then, I think that should be okay. And then, right, if you notice in the mark scheme, okay, they do also want you to close the file. So let's just use br.close. Right, I think that should be okay. Like, what I'm going to do, I'm just going to, okay, so, right, obviously here's the thing, right, you don't just have to use these files, so, you can also make your own files. So I'm just going to go stack data 2, and let's just create a simple file, like, I don't know, maybe A, let's say T, maybe E, I don't know, like Z, and let's say P or something. So, I mean, here what we've got 2 vowels and 3 consonants. And then, let's just try and actually use this one to test. Because, of course, it's going to be easier just to test, with 5 letters, right, rather than 100 letters. Right, so what do we want to do? I guess we want to call read data. And let's also make sure to change this to 2. Stack data 2. Right, and then I guess let's just also copy this, but we'll do it for the consonants. So let's go, stack consonant, and let's also go, consonant top. So I guess here what vowel top should be 2, because we pushed 2 vowels. Right, consonant top should be 3. And let's see if this is working. Okay, so we've got what AE, and then I guess just like an empty character, and then TZP. Right, so I think that should be okay, or TZP. Alright, so I think that's everything. Right, then the function pop val removes and returns the data at the top of stack val, and updates the relevant pointers. Again, pop consonant, right, does the same, but for the consonants. Right, if either stack is empty, the string no data must be returned. Right, okay, so let's copy this again. And hang on, let's just go, go down here. Let's just go back here then and demonstrate. Now, of course, okay, well, let's say we're on this one here, right, this T3. Now, of course, if we pop, well then, I mean, right, this is just going to decrement. And actually, like, I mean, we're not going to remove this C from the stack, right, because, I mean, all we're going to do is just, decrement and pointer. And then, of course, if we push again, let's say if we push D, well then, of course, I guess so first we would then, push D there. Right, and then of course, we would increment after, right, since it's pointing to the next one. And I guess here then, let's think, right, what's going to be the condition if the stack is empty. So, I think if T equals 0, right, that's going to be when the stack is empty. And like we can check that here, so right, here it's going to be 1. Right, then let's say if we pop, so if we pop, it's going to be back down to 0. And of course, I guess, right, the A would then be ignored in that case. So I think, right, that's going to be our condition. Right, so this is a function, and notice here that even though the vowel and consonants, right, they're only characters, we're actually going to have to return a string, since of course, this error message, right, this no data, right, that's going to be a string, right, it's not a single character. Right, so let's go public static, right, string. This is pop val. Right, okay, so I guess here we don't need any parameters, and let's just check then if the stack is empty. So this is going to be if val top equals 0. Right, then we want to say, well, just return, and yeah, that's going to be no data. And again, yeah, let's make sure to use the correct capitalizations. Right, then I guess what if it's not, then what do we want to do? We want to, yeah, okay, so like, right, let's think in this example then. Like currently the top pointer is going to be 1, so I guess what first we actually want to, yeah, decrement this, right, and then once we've decremented it, well, then we can, yeah, return the element at that position. Because obviously if we sort of get the element right at this position here 1 first, well, of course, right, that's just going to be empty. Yeah, or it's going to be, you know, a value from the previous time, yeah, kind of as we were, you know, pushing and popping before. So right, let's go, yeah, val top, right, just decrement that, and then we can just return, and that's going to be, right, it's going to be, yeah, stack val, and then right at this index val top. Yeah, that should be fine, but right, it's going to say, well, this is a car, right, not a car, right, a char. Right, so we can go more actions, and yeah, I guess, well, we can use this string.value of. I mean, probably there's also, yeah, I would think there's probably going to be what character. Yeah, okay, there's also going to be, right, character to string, so of course, yeah, we can also use that as well. And to be honest, right, another simple way, although I say this is not the most readable, but you, like, if you think here, well, if we concatenate an empty string with a character, well, if we ever do, right, a string concatenated with a character, right, of course, well, that's always going to become a string. But yeah, I think here, well, let's just use the one that they recommend. So yeah, let's say, right, string.value of. And again, you know, this is why, well, people think, right, Java is verbose, you know, there's a lot of code to write. But of course, I mean, since here, well, IntelliJ knows the return type, you know, it also knows the type of this, right, yeah, this array, right, therefore IntelliJ can actually help us out, you know, a lot with this. Whereas, for example, in Python, well, of course, you know, since we don't have to specify any data types, then yeah, the IDE is not actually able to help us, right? It's not able to give us, you know, good error messages, for example. Yeah, it's not able to, you know, detect errors in our code. Alright, so I think that's fine, and then, yeah, let's say here after this, so I'm just going to do s out. Right, and then let's, for example, just, I guess, I know, let's try and pop 4 times. Right, hang on, so, yeah, we'll just do that 4 times, and then, yeah, I guess what then we just want to maybe copy this again, right, just to see what the current output is. And actually, I think in this case, what we were only inserting 2 vowels, so here it's actually going to tell us it's empty twice. But yeah, I think that's fine. No. Okay, alright, hang on. So I realised that I should be, yeah, outputting this. Alright, yeah, let's try again. I mean, wait, so hang on, is that true that I guess we want to output? Hang on. Yeah, let's just read it again. Yeah, so removes and returns the data. Okay, right, let's just run this again. And yeah, okay, so we see what here, well, like E was going to be the top, right, so it's going to pop E first, right, then it pops A. Yeah, then of course we have 2 with no data. Now notice, I mean, of course, when we just print the array, well, A and E still exist, but since the pointer is 0, then effectively it's treating this as empty. And of course, if we then push something next, I know, like maybe a U, well, if we push U, then of course, well, this U is going to overwrite this A. And of course, well, like I guess the reason we're not actually, you know, sort of physically deleting this data is because, well, I mean, obviously, right, that's going to be an extra operation, right? It's going to take a little bit longer. Yeah, like we can just update the pointers without having to delete it. But alright, then I think, well, it just wants us to do a pop consonant, so let's just copy and paste this quickly. Right, and then that's going to be, right, consonant top. Right, yeah, consonant top. And then let's go, right, yeah, stack consonant. Right, so I think that's okay. Right, okay, so, yeah, okay, right, so then the next one, the program first needs to call read data, and then prompt the user to input their choice of vowel or consonant. Take as input the user's choice. Right, depending on the user's choice, call pop vowel, pop consonant, right, and store the return value. Right, okay, the 3 steps are repeated until 5 letters have been successfully returned and stored. And if either stack is empty, if either stack is empty at any stage, an appropriate message must be output. Okay, once 5 letters have been successfully returned and stored, they are output on one line. Right, for example, yeah, I guess what A, B, Y, T, I. Right, and then, well, okay, yeah, just write program code. And if we look at the next one, well, here is kind of what they want to test. So it's going to be what vowel, consonant. So I guess, well, we can just check, right, did they type in, I guess, yeah, we can check, did they type in exactly this? Or we can probably just use, V or C, right, that should also be fine, I think. Right, okay, so, yeah, alright, well, let's just copy all of this. Right, okay, and then, well, this is going to be in the main program. So, right, let's just delete all of this stuff then, because it's saying, well, we actually need to call read data first anyway. Right, so we want to prompt the user to input their choice. So to do that, well, yeah, to get user input, let's go scanner. Right, that's going to be new scanner. Right, then just, yeah, system in like this. And, right, so what I'm thinking we can do is, well, of course, we could do this with a count. And we say, well, every kind of valid, I guess, well, every time, they pop a vowel or consonant, right, and we actually get a valid value back, right, then, of course, we can just increment the count. And, yeah, of course, well, we're just going to loop that until, well, of course, until we reach 5. Right, or alternatively, like, we can literally just make a string. Let's call it, I guess, output. Right, just set that equal to an empty string. And then, of course, well, each time we can just concatenate the pop result to the output. And of course, well, like, only concatenate, right, if we actually get, the valid, I guess if we get, a valid return result. Right, if it says no data, then, of course, yeah, we won't, we won't concatenate that. And then, well, what we're going to do, we're just going to loop until this output length is 5. So yeah, I think let's just do that. If we go do, right, let's go while, and what we're going to loop until the output.length, right, is equal to 5. Right, and then so here, I guess we want to ask them, right, like, enter vowel or consonant. Yeah, okay, so let's go, let's say, like, yeah, would you like a vowel? Let's just say V, right, or consonant. Right, okay, yeah, if I can type. Right, and then, I guess we can, make a string for user choice. Yeah, okay, right, so let's go user choice. Right, and then the user choice, well, that's going to be scanner.nextLine. And then I think, yeah, and also, right, let's just convert this to lowercase. And I think what I'm going to do is I'm going to say, well, either they can enter V, right, or they can actually, type the whole thing vowel. So let's have an if statement then, and we say, right, if user choice dot equals, and right, let's go out if it's equal to V, yeah, or right, if user choice dot equals, and yeah, let's just say vowel. And of course, well, yeah, we've converted this to lowercase already, right? Therefore, that's why we only need to check this lowercase. Right, then, if it's this, I guess we want to call pop vowel. Okay, and again, well, this is going to be a string. So, yeah, let's just call that result. Right, that's going to be, right, pop vowel. And I suppose well, there's kind of a few ways we can check if it's valid. One, of course, what we can check that if it's not equal to no data, because if we just look at this, what if it's if it's empty, it's going to return no data. Right, or we can just check if the length is 1, because of course, if the length is 1, right, therefore it's going to be valid. Yeah, I guess just what a valid vowel. But I think I'm just going to check it's equal to no data, or yeah, we'll check it's not equal to no data. Right, so let's go, well, result.equals, and we'll say no data. And right, I'm just going to make this not. So of course, right here it's going to be valid. Right, then what do we want to do? I guess, right, so here's where we just want to concatenate with the output. And right, that's going to be result. And then right else, well, here's where we can just have the error message. Because, yeah, so here, right, an appropriate message must be output, right, if it's empty. So let's see what, yeah, can't pop vowel. Right, can't pop vowel. Yeah, well, let's say, like, vowel stack is empty. Alright, so I think that's fine, and then, yeah, right, well, let's just go S out, because, yeah, we want output at the end, and let's just have the output. Yeah, I think that's okay. And then what I'm going to do, so I'm just going to, well, let's just delete this stack size, and then, so here then, well, let's replace this stack size with 100. Because, of course, yeah, well, this was the stack size they tell us. And let's also go here, well, just, yeah, the original stack data again. Yeah, and then I think what I'm going to do, I'm just going to test it with the vowels, right, make sure it's working, and again, if this is working, well, then copy it for the consonants. Right, so would you like to pop a vowel? Well, let's say V. Okay, right, that's... Okay, alright, so of course, right, yeah, this is wrong. Like, see, I'm thinking in pseudocode, where of course if it's until, right, output length equals 5. But right, here it's going to be, well, not equal to 5, right, or we can say, yeah, less than 5. Right, so let's try again. Alright, let's go val. Yeah, okay. I mean, I think, yeah, I think like here we don't need to actually output what it, what it returns. Right, so let's actually try the whole thing, right, let's say val. Yeah, like if we try something completely random like ABC, right, so an AB, yeah, so I mean, well, ABC should have done nothing because of course it's not going to match this if statement. So let's go, what, 2 more, or I think, yeah, 3 more. And there, okay, yeah, so we get this. Alright, so I think that's working, and then, well, let's just copy this quickly then. So let's have an else. And we say, well, else if user choice equals C, right, or consonant. Right here it's going to be, well, pop consonant. And then, right, let's go consonant. And yeah, just consonant stack. Okay, and then I think that's fine, right? Then it says we just want to test it, so we want to go, what, val, I guess, what, val, 2 consonants, then 2 vowels, right, then take screenshot. So, well, let's try this and just see if it works. Right, so let's go V, right, then what, I think 2 consonants, right, then just 2 vowels at the end. And then if we look, we get, what, UT, yes, I guess we got 2 consonants, and then, yeah, 2 vowels at the end. And of course, I mean, well, you can just look at this, so it's going to be this one, right? So if we go to the end of the file, well, I guess, yeah, okay, because, well, okay, so we've popped this one first, right, that's why the T is here, right, then we have the X, since, yeah, we're concatenating, you know, sort of from left to right, and then I guess if we look at the vowels, what, the first vowel, should there be U? Yeah, so we see what, a U, right, then we get an O, right, then we get an E, yeah, so I think, right, that seems to be fine. Moving on to question 2, it says an integer is said to be divisible by another integer if the result of the division is also an integer. Right, for example, 10 is divisible by, well, 1, 2, 5, and 10, so, I mean, well, basically just the factors. Right, 10 is not divisible by 4 because, well, I guess, yeah, we get a decimal or a kind of real answer, or, yeah, non-integer answer. Right, so, yeah, okay, 1, 2, 5, and 10 is said to be the divisors of, of 10. Okay, yeah, I was looking for the pen and I think I just lost it. Right, the iterative function, iterative calculate, totals all the divisors of the integer parameter and returns the total. Right, example, so if the parameter is 10, the total will be 18. And what that's since, well, of course, yeah, the divisors of 10 were 1, 2, 5, and 10, right, just add them all together. Likewise, if the parameter is 4, well, of course, right, we can divide 4 by, yeah, 1, 2, and 4, right, therefore the total is going to be 7. Right, then a pseudocode algorithm for iterative calculate is shown. So it's going to take, well, the integer parameter, it's then going to return an integer. Right, so, well, then we're declaring a total. We've also got, well, to find, right, both of those are integers. Right, then they set the number. So, well, this number is the parameter. Right, they're setting that to be the total. So I think, well, yeah, let's kind of walk through this, right, or, you know, trace through it just with 10 as an example. So we say, well, this to find is going to be 10. Right, they're setting the total to 0. So here then, well, while number is not equal to 0, and then what they're saying, well, if to find modulus number, so we say, well, to find is 10, so effectively, well, 10 modulus 10 equals 0. Now, in this case, well, this is going to be true. So here, what we're going to do, well, we're going to do, right, total, of course, right, total is starting at 0, right, then plus the number, and what the number is, yeah, well, I guess the number is 10, right, in this case. So, of course, well, yeah, this is just adding to the total. Right, and then here, what we're just going to be decrementing the number. So, I mean, effectively, like, I mean, this might as well just be a for loop. If we're thinking in pseudocode, what they're doing really, like, well, let's say n, right? I mean, n is just number. Right, so for number, well, right, let's assign that 10. Right, then they're going, what, to 1? Because I guess, yeah, while it's not equal to 0. So, of course, it's going to stop when it hits 1, right? That's going to be, yeah, the last condition. Right, and then what, they're just using a step of -1. I mean, so, yeah, that's all they're doing here, right? Just a simple for loop, basically. Yeah, and then of course, well, if we go on the next iteration, well, the next iteration, this is going to be 9. But of course, well, 10 modulus 9, well, that's going to be 1, right? So it's not equal to 0. Then, of course, well, yeah, 8 is not, right? 7 is not. I guess, well, when they get to 5, well, of course, 5 will be 0. And of course, well, that's when, yeah, so what, in this case, what total is going to be 10. Then obviously, well, 10 plus 5, 15. Yeah, I mean, so, like, hopefully people can see, right, how we're kind of, yeah, arriving at this. And it says, well, yeah, the operator modulus calculates the remainder when one number is divided by another. So yeah, I think we kind of know that. Right, and then, well, then we just want to write program code for this iterative calculate. Okay, so let's just have this split screen. And yeah, I think I'm going to have to exit out of full screen here in order to do this. Yes, it's a little slow for some reason, I'm not sure why. Okay, so, right, let's go here then. Right, since it's a function, well, let's go right public static, and it's going to return an integer. Right, this is iterative calculate. And yeah, let's just sort of make that a bit smaller. Right, so this is going to take a number. And yeah, let's try and use, you know, the same sort of capitalization and things. Right, then we're going to have what, int total. Right, I guess, well, total is just going to be the number, so we can just, yeah, directly initialize that there. Yeah, kind of assign it. And then, wait, hang on, okay, no. Alright, so wait, total is 0. Right, total is 0, and then it's this, right, to find is going to be number. Yeah, okay, right, then we just want to loop, so what, while number is not equal to 0. Then we're going to go right if, so this is to find. Yeah, not timer. Okay, to find. And then, I mean, I think in Python, well, of course, yeah, Java and Python, you know, it's going to be the percentage sign is modulus. I think in VB, well, it's just going to be mod like that. Yeah, like, I mean, maybe I'm wrong for VB, but I think that's what it is. Right, so if to find modulus number, right, if that's equal to 0. Right, well, then we just want to go total, and, well, that's going to be total and then plus number. And of course, I mean, if you want, well, you can also use the shorthand, where I guess, what is it, yeah, plus equals number. Yeah, but I mean, for me, like, I don't really like that syntax. Yeah, I prefer just kind of doing it explicitly, really. Right, then if we just go number, and then, yeah, just, yeah, minus minus, right, just to decrement. Right, then I guess at the end, well, let's just return total. Right, so I think, yeah, hopefully that should work, and then, well, let's just test that. So let's go main. And let's go s out, right, iterative calculate, and what we want to try 10, and yeah, let's also try 4 as well. So what this should say 18 and 7. Yeah, let's see if this works. Yeah, okay, right, 18 and 7, so I think that's fine. Alright, and yeah, let's just go full screen again here then. Okay, so alright, well, okay, right, yeah, that's just what we do, that's what we've done. So write program code to call iterative calculate with 10 as the parameter. Yeah, so on this one, right, number 2, right, and output the return value. Right, well, save the program and, yeah, take a screenshot. Alright, so I think, yeah, well, obviously in the exam, make sure to do that. Right, then, right, iterative calculate has been rewritten as the recursive function, right, recursive value. A pseudocode algorithm for recursive values given the function is incomplete. Right, so here then, well, again, it's going to take the number. It's also going to take this to find. So this is now a parameter, right? It's not, yeah, it's not kind of you know, a local variable. Right, so let's think, well, what's going to be the base case when they return 0? And I mean, okay, right. So obviously in the exam, you don't have to write on this paper since, well, no one is going to get this. You know, it's just going to be like thrown in the bin. But I'm just going to try to write the answer here first. You know, then I'll just copy it across. Right, so I think here, well, the base case is going to be if it's 0, because, I mean, well, if it's 1, then, well, actually 1 is always going to be a factor, right? 1 is always going to be a divisor, so, you know, we're always going to want a plus 1. Yeah, I mean, to be honest, right, I think we could have, like, we could probably simplify this where, like, of course, we can't change this algorithm, but I think we could just go 1 and then probably just return 1, because again, right, 1 is always going to be, yeah, 1 is always going to be a divisor, but, well, of course, right, let's just keep it as they've done it. Right, so we go, right, if to find, and again, what this is just going to be mod. I guess, well, they say, yeah, modulus, but I'm just going to say mod. Right, then return, and, right, okay, so what here then, this is going to be the number that they've just added, or, well, yeah, the number that they've just got, so what this is going to be number. Because if we think, well, of course, right, if, let's say number starts at 10, well, if we find that 10 is a divisor of 10, well, then we just want to add this number, yeah, I guess, well, to the next call. Right, and then I guess what else is just going to be return here. And then this one, so I think what to find is going to be the same, because if we look at our original algorithm, well, to find we set here, right, but then, you know, if you look, right, we actually never update this. because yeah, I mean to find is just what well, that's going to be what we are. Yeah, okay. So well, of course, right. To find is what we're kind of doing the modulus on basically. So yeah, right. That's going to be to find. Right. So I think that should work. And then yeah, actually, right. Let's just split screen this again then. Right. Hang on. Right. Okay. And yeah, let's just minimize that. So here, I mean, like, yeah, maybe you can just copy the code you've already got, because I mean, there's not too many changes. But I think, well, let's just write it out again. So right, this is a recursive value. Right here, so it's going to hit, well, number is an integer. Right, there's also to find. Right, that's an integer. Right, so here let's write the base case. Right, if number is equal to 0. Right, just return 0. Right, then else, so right, if to find, if to find mod number is equal to 0, so I think just do it as we did before. Right, well then we want to return, and this is going to be the number. Right, well then then the general case, right, so the recursive call. Right, then of course we decrement the number, just to get 10, 9, 8, 7, right, as we did before, kind of simulating the loop effectively. Right, and then here, well, let's just go else. And then, well, actually here we can just copy this because it's just going to be the same. Yeah, and I guess that should work. Alright, because it, like, if we think, well, like, let's say if, I don't know, okay, well, let's say if none of them are, match this. Although, of course, well, that's never going to be true because, well, 1 is always going to, be a factor. But, I mean, let's just say, like, if it's 0, for example. Well, of course, right, it's always going to go to this condition, and then, finally, at the end, it's just going to return 0. But, well, of course, right, I mean, that's going to be impossible, right, since, of course, well, even 1 can be divisible by 1. Alright, so, let's just call this then, and, so, what, this should be 18 and 7. Okay, alright, so actually here then takes 2 parameters, and the second parameter is actually going to have to be the same as the number, right, they're going to be equal. And let's just see if this works. Okay, so 18 and 7, right, that seems okay. Right, hang on. Okay, not sure why the full screen wasn't working there. Right, and then, write program code for that, okay. Right, then it says write program code to call recursive value with 50 as first parameter and 50 as second parameter, right, and output the return value. Right, so, let's just try and do that then. So, of course, we'll just make that 50, make this 50, just see what it is. And then I'm also going to test it, just checking, this number 1, right, return 1. Alright, so 93. Now, will this also be the same if we do this? I mean, I think it should, but let's just try. Okay, right, so it seems this also works. Although, of course, in the exam, don't go, like, modifying their code, right, just, try and write it down directly. And again, we'll just test the program, take a screenshot of the output. So I think actually I think, some of those questions, right, converting recursive, or converting iterative to recursive, and vice versa, right, some are quite difficult, but I think in comparison, that was, like, relatively simple. Then the last question says, a computer game is written using object-oriented programming. The game has multiple characters. The class character stores data about the game characters. Each character has a name, date of birth, intelligence, and speed. Right, and of course, by character name, right, that's a string, date of birth, date, right, and then intelligence is real and speed is integer. Right, the methods, it's going to have a constructor which is going to initialize all four of those variables, or all 4 of those attributes. Right, there's going to be a getter and setter for intelligence, and I guess they're not going to do anything fancy, right, just get and set, right, there's no sort of validation. Right, then get name, right, okay, then, well, if we look return age, this is going to calculate and return the age of the character as an integer. So this is going to do some calculation. Right, and then learn is just going to increase the value of intelligence by 10%. Right, so we want to write program code to declare the class character and its constructor, do not declare other methods. Okay, so, right, let's just copy these then. Copy these attributes here, and hang on. Right, okay, so, I think what I'm going to do, well, I'm just going to go ahead and create this class, probably in a new file. Now, if you want, I mean, you can do it in the same file, but, like, I don't know, maybe let's keep it organized, right, we'll make another file. Okay, so here then, right, I'm just going to paste these, and I think what I'm going to do, well, let's just go string, Right, date of birth, well that's going to be date. Right, I mean for real, well we can go double. We could also say float. And in fact, hang on, let's just import this date. And right here then we want to import just this util, right? I mean not the SQL date, yeah, just the regular kind of built-in date. So I mean for real, well either we can use double, and double is going to be 64 bits, right, or we can use float, which is going to be 32 bits. Now of course, well double, since it's bigger, right, since you know it's double the amount of bits, right, then it's going to be more precise, and of course we can also represent a greater range. Right, so I think that's okay. Now I mean I will actually show you one trick here. Now of course, I mean, well we could just manually replace these like this. But let's say if you've got some complex, yeah, or I don't know, you know, okay, let's say you have like hundreds of these or something, or if you have, yeah, some, you know, complex thing that you want to like replace or find, then what we can do, well, we can use regex. So if we think then, well, what we want to replace, there's going to be a space, right? Then it's going to be a colon, right? Then it's going to be, well, I mean, I'm basically just like any character. So here we can write this, we can go, well, \s, right? That's going to be a space. Right, then we want to go colon. Then if we go dot, well dot means any character, and then if we go star, well this means 0 or more. Alright, so yeah, 0 or more instances of any character. Right, then we can just replace that with a semicolon, and if we just go replace, yeah, of course, right, that's going to replace all of them. So anyway, well let's just go ahead and create the constructor then. So right, let's go character, and yeah, let's choose the correct one. Right, so here, well, this is going to take a string, and I'm just going to use lowercase, right, just so we can differentiate the parameter, yeah, from the actual class attribute. Right, so that's going to be string character name. Let's go date, right, that's going to be, yeah, date of birth. Right, okay, we'll go double, well, that's going to be intelligence, and let's go, right, yeah, int speed, and of course, right, well, that's going to be, yeah, speed. Right, so in order to assign these, well, let's make sure we're using, yeah, let's make sure we're using the capitalized version, right, so that we're referring to the class instance. So here then, well, character name is going to be equal to name, right, date of birth is equal to, hang on, so again, right, yeah, okay, not date, yeah, okay, make sure to use the correct one, right, that's going to be equal to this lowercase date of birth, right, intelligence, yeah, that's of course equal to this one, and then, right, speed, yeah, that's equal to speed. Now, I mean, of course, right, we can do that manually. Again, right, if you've not seen the other videos, then of course, well, we can also just right click, we can also go to generate, and if we just go construct, and well, in this case, of course, we want to use, yeah, all of these attributes, and then you see here, right, IntelliJ is just going to do it for us. But I mean, yeah, since we've done it already, well, let's just use the one we've made. Right, okay, then the methods get intelligence, get name, return the attribute values, write program code for, well, yeah, the methods get intelligence and get name. Now, again, of course, if we just want to generate these get as well, of course, we just click here to generate, right, we go to getter, but I mean, yeah, let's just do it ourselves. So here then for intelligence, well, it's going to return a double, and I mean, honestly, well, let's just do this, what it tells us. So yeah, and I'm just going to capitalize it, okay, just to make sure it's the same as the, yeah, well, same as the exam. Right, of course, that's just going to return intelligence. Then if we just go, what, publish string, right, this is going to be get name. And then here, well, let's just go, right, return, and that's going to be character name. Yeah, okay, right, then the method set intelligence assigns the value of its parameter to the attribute. Right, then just write program code for, well, this setter. So again, of course, well, if we wanted, right, we could generate it, but let's just go public void. Right, this will be set intelligence, and then here it's going to take a parameter. Well, this will be a double parameter. Yeah, let's get intelligence, and then, well, like we did in the constructor, we're just going to get intelligence. And again, well, of course, right, this is the class instance, or yeah, the class instance attribute. And of course, yeah, just assign that the parameter value. Alright, then the method learn increases the current value of intelligence by 10%. Right, so I think for learn, I mean, well, since we've got a getter and setter, we can probably just use these. So, right, let's go public void, and right, this is going to be learn. So what we want to do, well, we want to call set intelligence, and well, that's going to have the value of get intelligence, well, and then just multiply by 1.1. Yeah, this should work. Now, I guess, like, in theory, we don't have to call this set intelligence or get intelligence, although I think probably we should, because, well, maybe later we might have to add some validation, right? Like, yeah, I don't know, like, maybe the intelligence can max out at 100, and of course, yeah, we can't have an intelligence greater than 100, right? I mean, you know, that's kind of the advantage of having setters, that, of course, yeah, we can include validation rules inside. Then the method return age calculates and return the age of the character in years as an integer. Right, assume that the current year is 2023 and only use the year from the date of birth for the calculation. For example, the method returns 18 if the character was born on any date in 2005. Right, so I guess what that's saying then is what we're doing. Well, 2023, which is what in the when the paper was written, the current year, and then we'll say 2023, right, minus minus the year of their date of birth, and of course, right, that's going to return 18 in this case. Right, so let's just try and write this then. So we want to go public int. Right, this is going to be return age. And then here, let's just go 2023, and then we want to go minus, I guess, right, the date of birth. And then to be honest, probably we can just use this one, right, date of birth get year. Now here it will actually say that this is deprecated because I guess now Java, they have a sort of more modern version, right, rather than this date class. But I mean, I think this one should still work, and this is also the way they do it in the mark scheme. Now, I mean, if you want, I guess you can search online. You can type in sort of, I don't know, kind of modern like Java date class or something. But yeah, again, in the mark scheme, this is what they use, right? And yeah, this should work. Then we want to write program code to create a new instance of character with the identifier first character. The name of the character is Royal, the date of birth is 1st of January 2019, and right, intelligence 70 and speed 30. Right, so let's just copy this. And yeah, if we just go back here, let's create this main method. Right, so I'm just going to paste in. Paste in the values here. Okay, there we go. Right, so what we're going to do then, we're going to create an instance of this character. So yeah, make sure to choose the correct one. Right, the identifier was first character. Right, and then if we just create a new instance, so let's go new character. Right, the name was going to be Royal. Right, then the date. So here then, we want to go new date. And then if we just pause this for a second, it should tell us the constructor. Okay, so here then, we can have a year, right, then a month, then a date. So let's just go the year is going to be 2019. Right, the date. So I think here, right, it's actually going to be 0. So the month is going to be index 0. Whereas, weirdly, the day is actually going to be index 1. And let's say like a 1-based index. Right, then intelligence, that was 70, and then speed was 30. Now here it's actually going to give us a warning, where it's going to say, rather than this 0, we can actually replace this with this enum, right? So let's go calendar.january. And of course, that makes it a little bit more explicit, right? It's easier to read. And it's saying, January actually has the value of 0. So of course, I mean, this is equivalent just to go in 0. But yeah, I think to actually do calendar.january, right, makes it more readable. Right, okay, so yeah, I think, that one should be fine. And then, I mean, I guess, if you want to test that, just the date, right, just to check that's working properly. If we just copy this, now it's going to be in some weird format, like especially the year. But we see, I guess, the date, right, Wednesday, the 1st of January, so yeah, this is okay. I mean, right, this year is a bit weird because, like, I don't know what this is, but I think they said it starts at some offset. Let's just see here. I don't know, so, like, I guess there's some weird, like, 1900 or something. I mean, there's some offset to this. But if we do actually just try the get year, then this get year will return 2019. Alright, so yeah, this should work. 2019. And again, I did check, this is also the way they do it in the mark scheme. So yeah, it should be fine. Right, then we want to write program code to call the method learn for the character created, in part, I guess the previous part, where I'll put the name, age, and intelligence of the character in an appropriate message. Okay, so, right, do we need to do that again? I don't know, maybe not. Like, honestly, I mean, the best way to do it is, if we go here to the character, then if we just go to string, right, then of course we can overwrite this. In fact, hang on, let's just go this one. Then let's go OK, right, just to generate that. And then what that's going to do is, of course, any time we just try to output the character, right, then it's just going to output this information. So let's just try that. Let's go S out, right, we'll go first character. And the thing is, right, I mean, of course, any Java class can implement this toString. and then of course, yeah, here we see all the data. Now, I think what I'm going to do, like, let's just try and format this a bit nice, yeah, maybe a bit better. So let's say maybe character, right, yeah, this can be character name. Right, hang on. And let's say, yeah, I know, maybe you write was born on, and then wait, so what do we want? Is it just the year? Okay, right, so well, the name, age, alright, intelligence. Okay, so, yeah, okay, alright, so let's say here then, right, is, and let's go, what, return age. Right, then we'll say years old. Right, let's say, yeah, and, I don't know, has an intelligence, maybe intelligence score of, and then let's go, what is it, get intelligence. Yeah, so that should be fine. And then of course, I mean, well, if you do this, then I would say, well, copy this. Yeah, of course, you know, copy this right into the, yeah, I guess, you know, evidence document. You know, and of course, well, copy this one, right? Or alternatively, well, yeah, of course, you would just have to, well, I guess, right, alternatively, you would have to do something like this, where let's just copy it. Right, I'm just gonna, yeah, comment that out. Then I guess, well, instead of printing that, let's just print, and well, then of course we have to go, right, character, and then what, this is going to be get name. In fact, hang on, right, not character, right, it's going to be first character. Right, that's going to be, yeah, okay, get name. Right, then, well, first character dot return age. And then here it's going to be, yeah, first character, right, dot get intelligence. Yeah, so of course, I mean, well, both of these methods should be acceptable, and let's just run this. Yeah, so character Royal is 4 years old and has an intelligence score of 70. Alright, so this seems okay. Now, of course, well, I mean, the advantages of just, well, doing it here in the toString is that if we create another instance of the character, you know, then, well, we're not going to have to copy and paste this code every single time. You know, of course, we can just easily output. Yeah, of course, you know, we can easily just output, you know, first character like this, or yeah, second character, third character. Yeah, we don't have to, you know, copy and paste this long formatting every time. Right, okay, so well, then we want to call learn, and right, okay, alright, so well, first we want to call learn before that then. Yeah, so let's just check if this is working. So right, first character dot learn, and of course what this should now say 77 for their intelligence. Yeah, okay, so I think this is okay. Right, and then we'll just take a screenshot. Right, then the class magic character inherits from the class character. A magic character has an element, for example, water. Right, this element changes how they learn. The magic character's element is stored in the additional attribute element. Right, okay, so this is going to inherit them from, yeah, inherits from character. Right, so the constructor takes, well, element, character name, right, well, I guess, yeah, the other 4 parameters. And it's going to call the parent class constructor with the appropriate values. It's also going to initialize element to its parameter value. Right, and then, well, I guess learn we're then going to override. So this is going to alter the intelligence of the character depending on the character's element. Right, so first then we just want to write program code to declare the class magic character and its constructor. Right, do not declare the other method. Alright, so yeah, let's just copy these. And right, what I'm going to do then, so yeah, let's just go in this package again, and we'll just go new. Right, so this is going to be what, new class, and let's call it magic character. Right here then we want to go what, extends character, and yeah, wait, is that the right one? Yeah, okay. Right, I mean, so here what it's going to say, we need to, yeah, I guess, well, there's no constructor. So to be honest, I'm just going to do this, right, create constructor matching super. Yeah, or alternatively, like if we want to do that, well, we want to go, what, magic character. And well, of course, right, then we'd have to type them all individually. So I think, yeah, here, let's just do it. It's going to be a lot quicker. Right, okay, so yeah, here that's fine, right, and then it's saying what we've got the character name, the date of birth, right, the intelligence and speed, but we also want the element, right, and I think they said what the element is going to be a string. And then, right, let's go here then, so, right, string element, yeah, just create the class instance, right, or yeah, well, the instance variable. Now, I don't know, like, can we do this before? Yeah, maybe not. It's probably going to say we have to call super first. Yeah, okay, right. So in this case, well, first we have to create the, yeah, I guess, well, we have to call the, yeah, sort of base constructor or the parent constructor. Right, yeah, then we can, right, assign this parameter, you know, to the class variable. Alright, yeah, so I think that's okay. Right, then the method learn, yeah, overrides the parent class. Right, okay, and yeah, so I think we said this. Right, so let's copy this then, and we just, I mean, probably we can just, well, I mean, either we can have if statements, right, or we can do a switch. Yeah, okay. So I think probably I'm just going to do a switch, and let's just go public. Right, I think that was going to be void, and then, yeah, if we just go learn. Right, so of course, well, this should override, and yeah, let's just paste that in there. Yeah, I mean, well, okay, so I think, well, previously I did a switch for the other one, so let's actually just use an if statement here then. Right, let's go element, and right, let's go equals. So here we go, what equals fire. Yeah, or we go what element dot equals water. And you know, to be honest, I think, yeah, I don't know, like maybe here we can just convert to lowercase. I mean, yeah, probably they won't require us to check that. Right, so in this case then, what do we want to do? I mean, right, I guess, well, I mean, let's just copy it from here. So, yeah, I guess what we can copy this. And then, right, so here, well, it's just going to be 1.2. Right, I'm just going to copy this, then, well, let's have an else. So we get else if. Right, and then what else if is equal to earth. Right, and then what this is going to be, well, times 1.3. Right, then I guess what else? Yeah, okay, what else is just increased by 10%. And to be honest, like, if we want to do that, like, we could just call super dot learn, because of course, well, the super learn, right, this is the default one, and we see here, right, this is just increasing by 10%. Yeah, so I think that's okay. Right, then, well, again, I guess they're probably going to ask us to, yeah, check this. Like, let's say an alternate way, you know, I don't know, if we had like hundreds of different elements, then another way to do this, well, I mean, you could create a, let's say a hash map, right, or a dictionary, where you would do something like this. Let's just do this quickly. So we'll go, yeah, I mean, let's make it maybe static, or yeah, can we do that inside here? Okay, all right, yeah, maybe not. I mean, probably you would create another class, right, just storing, just storing these mappings. But for example, well, you can go hash map, right, and then we want to say, okay, so well here then, right, the key is going to be a string, right, and then what the value is going to be, well, I guess the value is going to be a double, yeah, or float. And let's call this maybe, I don't know, maybe yeah, element modifier, or yeah, in an element like multiplication or something. Right, so that's going to be equal to new hash map. Yeah, and then, like, to be honest, right, I mean, this is not the most efficient because, well, here it's going to create a new instance of the hash map, right, for every instance of this magic character, right? I mean, that's why we would want to create this in another file, okay, make it static, and then in that case, we're only going to have one instance of them. I mean, yeah, can we do, okay, alright, so actually, right here, we can just make it static, and yeah, I think that should only create one instance. But yeah, I mean, the problem is, like, here we can actually, yeah, okay, so, well, we'd have to then go here in the, right, in the constructor. So, for example, we can go element modifier, right, let's just go put, and for example, well, let's say fire, right, and then, for example, we just go, what, 1.2. Yeah, and then right inside here, instead of having, you know, this element dot equals, right, you know, over and over again, we could just say this, and we could go, right, let's say, yeah, if element modifier, right, dot, let's go contains key, and we say, well, if it contains the element, right, then what we're going to do, well, we're just going to call this set intelligence, and then rather than multiplying by 1.2, what we're going to multiply this by, what element modifier, right, then I guess get, and yeah, then we're just going to get the element. So what this is saying, well, I mean, this is going to get the value, right, that corresponds to this key. So let's say in this case, well, if the key is fire, then we say, well, yeah, the value for fire is going to be 1.2. So I mean, this whole thing here, right, I mean, this is just going to be 1.2. Then, of course, well, here we would just have the else, then yeah, inside the else, we would just have the super.learn. Right, so yeah, I'm probably just going to try both methods, right, see if they work. Although, of course, you know, for the exam, right, you can just keep it simple like this. Right, yeah, so let's go to this one then, and probably they're going to tell us to, yeah, create some characters. Right, so, okay, so it's called First Magic. Right, okay, and then, yeah, let's just try and create this. And yeah, we'll minimize that. Alright, so this is going to be, yeah, magic character, right, the identifier is going to be First Magic, so, right, let's go new magic character. Right, the name is light, the date of birth, right, so this is going to be 2018, and then we're here, right, let's go calendar.march, and then that's just going to be 3. Right, the intelligence is 75, right, speed is 22, and yeah, I think actually, so first here, right, yeah, the element should be the first one, so here then the element is fire. Alright, and obviously, I mean, that's why it's quite good, you know, IntelliJ actually tells us the, yeah, I guess tells us the, you know, parameter names. Alright, so yeah, that should be okay, I think, and then what do we want to do? So we want to call learn, and then again, we'll output the name, age, intelligence, right, in an appropriate message. Yeah, so I guess basically we're just copying the output that we have for this one. Or yeah, I mean, kind of copying both of these really. So here what's going to be, okay, right, first magic.learn, and then, yeah, let's say, right, first magic. Alright, so let's think what this should be then. If it's 75 and, right, fire, so fire was that 1.2. Yeah, so I mean, that's going to be, I guess, what, 75, well, sort of 75, yeah, times 1.2. Well, of course, it's going to be, what, 7.5 is 10%, or therefore 20% should be 15. So yeah, I think this should go to 90. Let's just have a look. And yeah, okay, so intelligence is 90. Alright, so I think this is working then. If we just go here, well, let's also try the hash map implementation. Right, so we'll just uncomment those, and yeah, let's just comment these. And well, let's just run this again. And I mean, hopefully it should still work. And yeah, 90. Now, of course, again, I mean, like, well, for this simple exam, you know, of course, you know, just use an else statement like this. But if, I don't know, well, let's say if you're making a real game and you have, like, yeah, 50 different, I don't know, yeah, like 50 different modifiers. Right, I've also made it where, for example, if you think of games, I don't know, like Pokemon or, yeah, some other kind of game, where, of course, let's say you've got, like, 20 different types, and each type, of course, has different modifiers against a different type. So, for example, you know, fire versus water, well, fire is going to be weak, but then, you know, fire versus grass, well, in that case, you know, obviously fire is going to be strong. So, of course, there, if you have, what, like 20 times 20, what, you're going to have, like, I guess, you know, 400 different combinations. Yeah, or in fact, probably less than that, right, because you're probably, you know, only multiplying by 19, right, like, I don't know, yeah, maybe 380 different combinations. Now, obviously, in that case, you're not really going to want to have, like, 380 different if statements. So yeah, that's why using, right, something like a hash map can be, yeah, I guess just more kind of flexible, or more, yeah, kind of easier to maintain, I guess. Alright, so yeah, is there anything else? Right, then just test the program and yeah, take a screenshot. Alright guys, so again, I mean, well, hopefully that video is useful. I mean, any questions, well, just ask in the comments, and see you again in the next video.